So we just finished doing long division, and if you just had a smaller one, it wasn't too bad, but you had a lot of bigger ones there on Delta Math. So there's got to be a better way, and there is. There's something called synthetic division. Here's the steps for it. Of course, you know me, I like to just do an example. So the first thing, there's kind of a couple rules for this. First, I really need to have x by itself here. No coefficients with that x. The second thing that I really needed to make sure is that all of my spots, I kind of call them the spots, are accounted for. So you should always have a constant. That's the one number that doesn't have any variables. And then your, kind of x to the first, squared, third, fourth, fifth, sixth. As far as the pattern goes, you need to make sure you have them all. So since this one has them all, this one's a great problem to start with. What I want you to do is start by just bringing down all the coefficients. Okay? Then, when we did long division, if you recall, you kind of had, when we would do that x plus 3, you were subtracting down. I'm going to take care of that subtraction by using this number here, the 3, but I'm going to just do a opposite of that. So since it was a positive 3, I'm going to use a negative 3. If it had been a negative 3, then I would make it a positive 3. So then leave some space, draw a line. The very first coefficient, or the first number, you're just going to drop that down. So 2. Then you're just going to multiply diagonally, add down. So check it out. Ready? Multiply. 2 times negative 3 is negative 6. Add down. 3 plus a negative 6 is negative 3. Multiply. Negative 3 times negative 3 is a positive 9. Add down. Negative 4 plus 9 is 5. Multiply diagonally. 5 times negative 3, still multiplying by this negative 3 this whole time, is negative 15. Add down. 15 plus negative 15 is 0. That's all the math you have to do. Now you need to tell me the answer as an actual polynomial. Right now you just have a bunch of gibberish. So the very far right thing is always going to be your remainder. Then the constant, x, x squared, x cubed, x to the fourth, keep going until you run out of numbers. So my final answer is 2x squared minus 3x plus 5. That's the answer. So let's check out one. Oh, here's kind of the math as to why that works. Again, you're dealing only with these coefficients when they are 1, adding down instead of subtracting down, because we take care of the fact that it was the subtraction by doing the opposite. So let's do an example where it's maybe a little more complicated. Here on 5a, I notice, first of all, that it's not a 1 there. So I'm going to need to get rid of that 2. I'm going to divide everything by 2. Which is going to give me 4x to the fourth minus 2x squared plus a half x plus 2. And the whole thing is being divided by x plus 1/2. So now that means the number in the box gets to be a negative 1/2. And drop down the coefficients. 4, negative 2. Oh, wait. I forgot to talk about this issue. Double check that all your numbers that you need are represented. Here's the constant. X to the first, x to the second. There's no x cubed. If you are missing one, like in this case where I am missing the x cubed, the coefficient for that must have been 0x cubed, because that 0 is what would allow it to cancel, right? So what I need to do now is just bring down all those coefficients, including the 0. Did I get them all? Yes. Okay. Now, go ahead and pull the 4 down, then multiply, add, multiply, add. 4 times negative 1/2 is negative 2. Add that down, it's negative 2. Negative 2 times negative 1/2 is negative times negative would be positive 1. Add down is negative 1. Positive 1/2 is 1. Negative 1/2, you now have, let's put it in improper fraction form, 3/2. So this is the remainder, constant, x squared, x cubed. So my answer wants to be 4x cubed minus 2x squared minus x plus 1. And then don't forget the remainder is going to be the number that's left over, so 3/2 over what you were dividing by. I was not dividing by 2x plus 1. I was dividing by x plus 1/2, right? Because I did that division of 2. So x plus 1/2 here. And here's the problem. In a simplified fraction, we don't like to see fractions inside of fractions. So just this fraction here, I'm going to multiply it by 2 over 2, because what that will do is turn that into like 6 over 2 or just 3 on top, and distribute on the bottom here is going to be a 2x plus 1 conveniently. Notice it kind of turns out to be the same thing right there. And then we can go ahead and copy down the rest of that answer. Like so. All right, that's it.